Alright, my name is Kelsey Potts, and I am going to be talking about the third problem on our expert TA assignment. So this problem is, suppose you have a 130 kilogram wooden crate resting on a wood floor. The coefficients of static and kinetic friction are 0.5 and 0.3 respectively. And then in part A, they are asking what maximum force in newtons can you exert horizontally on the crate without moving it? And then for part B, if you continue to exert this force once the crate starts to slip, what will its acceleration be? So for this problem, the strategy that we can use is to just look at what we know first. So what we know is that our mass is 130 kilograms, and the static coefficient is 0.5, and the kinetic coefficient is 0.3. So then we can draw a free body diagram, which I have drawn here for you. So here's our crate. In the positive up direction, we have normal force. To the right, in the positive x direction, we have our maximum force. And this is also the force that we are exerting on the crate. And then downwards, we have the force of gravity. And then to the left, in the negative x direction, we have our force of friction or static force, or F static. So for this, for part A, we are trying to find the maximum force in newtons. So for this, we can do net force equals mass times acceleration, and then your maximum force minus your static force, which this is basically saying that your maximum force is equal to your static force. So then, to solve for our maximum force, we can take the coefficient, our static coefficient times mass times acceleration of gravity. So 0.5 times 130 times 9.8. And for this, we will get 637 newtons. And then it is important to remember that your F max equals your F stat. So this is going to be both of those. And that could be a pitfall if you just assume that they are not equal. So then in part B, we are trying to find the acceleration if we continue to exert that force once the crate starts to slip. So for this, we can take mass times acceleration equals our F max that we just found minus our kinetic force. So first we'll have to find our kinetic force, and by that we can take our coefficient times our mass times acceleration, so 0.3 times 130 times 9.8, you'll get 382.2 newtons. And then you can plug that into this equation, the mass times acceleration equals F max minus your kinetic force. So you'll take 637, which we found in part A, minus what you just found, the 382.2, and then divide that by 130, or your mass, and then you'll get an acceleration of 1.96 meters per second squared. And then to calculate the force needed to start moving the crate, you can just do your force equals mass times acceleration. And that is how you solve this problem.